All right, hello everyone. Today's focus is going to be on voltage drop testing. Yesterday we looked at battery load testing. Today we're going to look at how we can test the condition of the cable that goes between the battery and the starter motor, as well as looking at the condition between the battery ground and the starter motor ground, and also looking at the condition really of any cable that connects any electrical component using this test. So this is a valuable test not just on starting systems, but on any component that you happen to be working on.
So, in order to understand voltage drop, we need to review three important terms: voltage, current, and resistance. And remember that these three terms interact with each other in something called Ohm's law, which we'll address as we go through this. So, in order to understand this, we're going to use water as our example because we can see water, we can't see electric current. So, we have water stored in a tank. It's stored in a tank, meaning it has potential or pressure. So that is going to represent our voltage. Right now, there is no current flow because our valve is closed. So therefore, we have no current. We do have a restriction, so we do have resistance. In fact, our resistance in this case is so high that it's preventing any current flow. So this would be like in the case of having an insulated material that's not allowing the flow of current. We have such a high resistance that current flow is impossible, and therefore we're not seeing any current flow. In the second example, we have voltage, and we also have a resistance in the form of this valve, but there is some current flow, which is represented by the water flowing out of the tank. So that is the concept of voltage, current, and resistance. When we discussed Ohm's law, you learned that current, which again we're going to actually represent with the symbol for current, which is an I. So current is equal to voltage divided by resistance. So what does this really all mean? Well, if we increase the voltage, increase the pressure, we're going to have more current flow. If we increase the resistance, like we did here, we're going to see a decrease in current flow all the way to where we could have almost no current flow, or in the water example, absolutely no current flow. So why is all of this important when we're trying to understand something like a starting system? Well, let's look at how all of this works together. Let's say we were able to use a device to measure a difference in pressure between 2 points. So for example, we had a meter that we could connect that would measure, remember, voltage is electrical pressure, and we could connect this thing at 2 points and we could measure a difference in pressure between 2 points. Well, what would we be seeing in this case? In this case, we would be seeing a pressure drop equal to the total voltage. So let's say our voltage in this case is 12 volts, sticking with the car battery theme. The difference in pressure that we're going to see between this point and this point is going to be our full voltage of our battery. So in this case, when we take that measurement, we're going to see 12 volts of potential or pressure. When we open our valve and current starts to flow, there is still going to be pressure here, but we may see a drop. So maybe instead of 12 volts here, we're going to see a drop in pressure to 10 volts. Okay? So we're going to see maybe 10 volts here. Why is this important? Why is this happening, I should say? Well, we're dropping that pressure. As current is flowing, we're seeing a decrease in pressure. It makes logical sense to us. Where is that pressure going? It's dropping across our resistance. And if we took this same device that was capable of measuring a difference in pressure, and we measured the difference in pressure between these 2 points, we would see that drop. Likely, what we would see here is a difference in pressure of 2 volts. Now, I get that volts represent electricity, not actual pressure with water, but I'm trying to use this as a visual so that you can understand what is actually happening here.
What I want to show you here is voltage drop testing where you can actually see the connections in front of you. When we do this on the vehicle, I can't show you all the connections at once because I can only have the camera at one point. Okay, so now we're going to do a voltage drop test. And what a voltage drop test is going to tell us is how much of this voltage is dropping, or actually are we losing, in this battery cable. In order to do that, we're going to connect our leads now to both ends of the same cable. One to the battery, one directed to the starter motor. The same thing we're going to be doing on the vehicle. It's just you won't be able to see this when we're on the actual vehicle. So again, one end of our wire, one lead is on our positive battery terminal. The other lead is on our starter motor. We're gonna go ahead and run the starter motor. Now, right now we're seeing a reading of 0 volts. We wanna see that reading maintain very close to 0 volts. The higher that number, the more voltage we are losing or dropping in that battery cable. We can use this to test any wire where we suspect a bad connection or a bad wire. It's not just starting systems. It's just the most pronounced in starting systems because starter motors draw so much current. Remember, we said that starter motors are one of the highest draw, probably the highest draw device on a vehicle. So another change that I'm going to make is I'm going to switch down to the millivolt scale. So we're going to go down to the 200 millivolt scale. What this means is that what we're going to be reading on our meter is actually not volts. It is going to be thousandths of a volt. So we'll go ahead and we'll run our test with the meter connected to both ends of the same wire. And we see a reading at most of about 12 millivolts. That's about 12 thousandths of a volt voltage drop. That is a minimal voltage drop. So in this case, our wire is able to carry the current, and we're seeing very little drop in voltage between the battery and the starter. This tells us that we have a good connection between the battery and the starter. Now, some people would say, why do a voltage drop test? We learned about resistance. Why can't we just measure the resistance of the wire and determine if the wire is good based on the resistance in the wire? So I want to show you a little demonstration of why this doesn't work. So we have 2 wires here. This was the healthy battery cable that was being used in the last demonstration. And I'm going to go ahead and I'm going to measure the resistance across this. So I'm going to go down to my ohm scale, and I'm going to set my scale on 200 ohms. And when I put my leads across the ends of this wire, I find out that this wire has approximately 1.0 ohms across it. All right, so there's 1 ohm of resistance through this cable. Then I'm going to take this little jumper wire, this little 16 gauge jumper wire, which is way too small to use as a starter wire, but just for the sake of understanding, I'm going to go ahead and I'm going to make a connection across the 2 ends of this jumper wire. And when I make my connection across the 2 ends of this jumper wire, I get a reading of about 1.1 ohms, somewhere in that neighborhood. So I have about 0.1 ohm more resistance in this wire than I do in this wire. So I would say comparably that these 2 wires have about the same amount of resistance. But the question is, what's going to happen if I connect this jumper wire and try to spin this starter motor through this jumper wire? So let's look at what that actually looks like. Okay, for the sake of demonstration, I have taken my little 16 gauge jumper wire, I've replaced my battery cable that should be there with this 16 gauge jumper wire, and I now have my multimeter set up on both ends of that jumper wire, one end to the battery, one end to the starter motor. What I'm trying to demonstrate to you here is what would happen in the case of a bad cable. Not that this wire is bad, but it's significantly undersized for my starter motor. Also, I want to remind you of the fact that there is no mechanical load right now on this starter. If there was a mechanical load on this starter would not turn at all. In fact, you're going to see it's going to run very slow. To not damage the starter motor, the battery, or melt the wire, I'm going to keep this test very short. So you're going to have to be watching the meter closely. I'm just going to bump this for a second. Also, I have switched off of the millivolt scale because I'm anticipating what's going to happen is I'm going to see a much higher reading than I can read with the 200 millivolt scale. So I'm actually back to my 20 volt DC scale. So watch this meter as I bump this and see what happens. And we see a little puff of smoke actually off of the wire. If you watch the meter closely, you saw the reading go up to about 5 volts. So what was happening in this case is I was dropping the voltage across this wire by 5 volts. That means the starter motor, which is meant to see 12 volts, was only seeing 7 volts, which is why you heard the reduced speed of the starter motor, even with no load on it. You saw the puff of smoke from our wire because our wire got hot very quickly, and you saw the high voltage drop. Now, this is obviously a very dramatic situation, but it points out the fact that 2 wires with very similar resistance, when they're put into a high current situation, perform very differently, and we see a much higher voltage drop. This is why voltage drop testing can be very, very useful, not just on starter systems, but finding connection issues with any electrical component.
Let's take this one step further and look at why this actually happens. And let's look at why just strictly measuring resistance in a circuit doesn't work. So let's take something like a battery cable. So if you were to cut apart a typical healthy battery cable, what you would see is that you have an insulator that runs around the outside of that cable. And inside that cable, you have these strands that run through the cable, these strands of wire. And I'm drawing this, obviously there are thousands of them. I'm just drawing a few so you get the idea. But we have these strands of copper that are running through this wire and that are all working together in order to be able to carry the current through the wire. Well, this would be, let's say, a healthy wire. Let's take, for example, a wire that is not healthy. And let's say that if we were to cut this wire apart, what we have happening is we have some of the strands broken inside the wire. So now we have really just one strand through a portion of the wire that's making the connection. So we've got corrosion in this wire. We've got something that's causing this wire. This wire is deteriorated. So we still have an electrical connection through this wire, but we're down to just a couple of strands worth of connection. If I were to come along with my ohm meter and I was to measure the resistance of this wire, I would probably notice that when I placed my leads on this wire to measure resistance, I would get a very, very, let's say, low resistance. So, and let's just say, for example, that my resistance is going to be 10 milliohms of resistance. Okay, 10, that's not mega ohms, that's milliohms of resistance. So I do the same test on this wire, and I find that I have a resistance of 11 milliohms. It's 11 thousandths of an ohm. Am I really going to be concerned with this? No, because I'm going to look at this and go, one extra thousandth of an ohm resistance? No, that wire looks fine to me. Okay, because and why does this happen? What we have to look at is we have to look at what a multimeter does when it measures resistance. A multimeter puts out a very, very small amount of current and uses Ohm's law to calculate the amount of resistance through that circuit. The problem with this is, remember, voltage drop becomes more pronounced the more current we have flowing through the circuit. Well, a multimeter may push out a couple milliamps of current through the circuit. Very, very small amount of current. Remember, we talked about the fact that a starter circuit can pull hundreds of amps of current. So what happens in that case? Well, when you try to put hundreds of amps through this circuit, you are going to see a huge voltage drop between this point and this point. Whereas here, you may see a very small voltage drop. So as soon as you try to put any kind of real current through this circuit, you're going to see a very, very large voltage drop through this circuit.
So currently I have my meter connected, one end to my starter motor, to the battery cable on my starter motor. The other end is connected to the positive side of my battery. When I'm cranking my engine, remember, I'm looking for the lowest amount of voltage drop possible. During that crank, notice we saw approximately 0.2 volts, about 200 millivolts of voltage drop. Very, very minimal voltage drop. That tells me that my connection between my battery and the positive side of my starter motor is very good, and everything is functioning as it's supposed to be, which is what we want to see in this case. I'm going to show you a second way that you can go forward and do this test. What I'm going to do now is I'm going to go ahead and switch my cable over from the positive side of my battery to the negative. And I'm going to go ahead and crank the engine in the same way. Notice that my voltage started right around battery voltage, a little low to start with because I've been cranking this engine quite a bit doing these tests and have not restarted it. We do have to be careful doing these tests so we don't drain our battery down. It's a good idea once in a while to reconnect things and fire the engine up. But notice we started it at about 11.8 volts, and we dropped down to 10 and change during the crank. That was voltage that was being lost between the battery and the starter motor. So two different ways that we can do that test. Both tests show that our cables, our connections from our starter motor to our battery are good. If we were having a cranking issue, we would want to be looking somewhere else for the cause of the problem. So hopefully you've enjoyed this video. Again, we're going to continue with some of these demonstrations of some of the different aspects of testing electrical systems on vehicles.